Here I'm going to explain the closed interval test. So let's say we've got some interval that we want to find a maxima and minima for some function. So we want to find the highest value and the lowest value for a function. So let's say the following. Okay, we've got a function f. So let f be our function that we're interested in. A minimum and a max. Okay, let's assume the following. So we'll assume 1, that f is continuous. On the interval, on the closed interval, AB. Okay, and we're also going to assume 2, that it's differentiable on the open interval AB. Now it can't be differentiable on the closed interval AB because at points A and points B, at A and B, if you're only talking over a certain interval, then at those very endpoints you don't have a derivative because you don't have a limit coming from the left or from the right. And so when we talk about continuity on a closed interval, these we're talking about as continuous on the open interval, and then right continuous from here and left continuous from here. Okay. So what we're going to do now is we're going to get a list of suspects. For the minimums and the maximums. Okay, and how we're going to get that list is we're going to take a look at all the critical points. Okay, so step number 1 is look at all critical values on the open interval AB. This is done by taking f prime of x and setting it equal to 0 and solving. Okay, then 2, we're going to look at the values of the function at the endpoints. So look at the values of f at the endpoints of the interval. Okay, so essentially we're going to compute f at A and f at B. Okay, what we're going to do then is we're going to take those values. We're going to take all of these guys. So let's say this produces a couple critical points, x1, x2, all the way through, I don't know, xn. And then we got these two guys. What we're going to do is we're going to look at the values associated with f of x1, f of x2, f of xn, and also f at A and f at B. The largest of these will be the maximum, and the smallest of them will be the minimum of the function on that interval. Okay, so let's go ahead. I'm going to do example number 4, and we're going to go ahead and look to see if we can find minimums and maximums on a closed interval.